Every single app you use, every website you visit, it's all standing on a massive foundation of data. But how do you actually build that foundation so it doesn't just crack under pressure? Well, today we're going to look at the blueprint that makes it all possible.
I mean, seriously, think about it for a second. You wouldn't just show up with some shovels and start stacking bricks, would you? Of course not. The risk of a total, catastrophic failure is just way too high. The answer is obvious. You start with a plan.
And just like that skyscraper, our most important apps and services, they're all built on that same kind of foundation, the database. An unplanned database is just as dangerous as an unplanned building. We're talking data loss, terrible performance, and a whole lot of wasted time and money. It's a disaster waiting to happen.
So, how do we avoid all that chaos? Easy. We use a blueprint. And in the world of data, that blueprint has a name: the Database Development Lifecycle. It's a structured, methodical approach that helps us turn a complex idea into a super robust and reliable system.
Okay, so this right here, this is our roadmap. It's the master blueprint for building a database from the ground up. Now, I know it might look a little complex, but trust me, it's a proven path that takes you from a simple idea to a powerful, rock-solid system. Every phase we're about to cover is designed to prevent failures and make sure the final structure is sound. So let's kick things off at the very beginning.
All right, phase 1. This is all about the vision. Before a single line of code gets written, before any tables are created, you have to know why you're building this thing in the first place. This is just like that first big meeting between the architects, the city planners, and the future tenants of our skyscraper. Everyone has got to be on the same page about what this thing is for.
And that journey starts with a simple mission statement. This is your North Star for the entire project. Are we building a system to help a hospital manage patient records instantly and securely? Or are we creating a database to power a streaming services recommendation engine? This statement defines what success looks like and keeps the whole team pulling in the same direction.
Once that mission is crystal clear, you got to go talk to the people who will actually be using the thing. In the biz, we call their perspectives user views. You need to know what data the sales team needs, how the marketing team plans to use it, and what the folks in logistics require to do their jobs. Forgetting a key user view here is like building that skyscraper and completely forgetting to design a lobby for the people inside. Not good.
So you've got all these requirements flooding in from different teams. How on earth do you manage it all? Well, there are basically two main strategies. The centralized approach is where you merge everyone's wish list into one giant document right from the start. Or you can use the view integration approach, which keeps them separate, builds mini models for each user group, and then merges those models later.
And this visualizes the difference perfectly. On the left, the centralized approach is like trying to funnel everything into one massive document all at once, which, you can imagine, gets chaotic fast. But on the right, the view integration approach lets you build these clean, separate, manageable models for each group, and then you just piece them together. For really complex projects, this is often the way to go because it keeps things organized and makes it way easier to spot problems early.
Okay, with our requirements all gathered and organized, we can finally move to the design phase. This is where the architects take all that information and start drawing up the detailed plans for our digital skyscraper. And it happens in 3 distinct layers.
First up, you have the conceptual design. Just think of this as the high-level artist's sketch. It shows the building's overall shape and function. Next is the logical design. This is like the detailed floor plans, showing all the rooms and how they connect, but without getting into, say, the brand of drywall. And finally, there's the physical design. These are the hardcore engineering specs that detail the exact steel beams, the concrete mix, and all the electrical wiring needed.
The conceptual design is all about the what, not the how. It's a model of the data that's totally independent of any specific technology. We're not thinking about which server to use or what software we'll buy. At this stage, we are purely focused on modeling the business needs we gathered back in phase 1.
Now, the architect's favorite tool here is called an Entity Relationship Diagram, or ERD for short, and it's simpler than it sounds. Think of the entities, the rectangles, as nouns: a customer, a salesperson, a sale. And the relationships, the diamonds, are the verbs. A salesperson handles a sale, which is sold to a customer. This simple diagram gives you a perfect visual map of the core logic of the business.
So, with that conceptual plan in place, we move to the logical design. This is where we translate that abstract ERD into a concrete structure, like the tables you see here. It's kind of like turning a floor plan into a list of rooms with their exact dimensions. Then, we get to the physical design, and this is all about the hardware.
We decide exactly how these tables are going to live on servers, how data is stored on disks, and how we can create indexes, which are basically like a books index, to find information incredibly fast.
So what makes a blueprint a great blueprint? Well, it really comes down to 4 key things. A great design is simple enough for everyone to understand, but also expressive enough to handle all the complexity. It's non-redundant, because storing the same information in multiple places is an absolute recipe for disaster. And maybe most importantly, it's extensible. It's built not just for today's needs, but ready to grow with the business tomorrow.
With a solid blueprint in hand, it is finally time to break ground. Phase 3 is where we move from planning to doing. This is the construction phase, where that beautiful design gets turned into a functional, working database.
Now, this involves 2 huge activities that run at the same time. First, you've got implementation. That's the actual construction of the database tables and loading in all the data. But just as important is testing. This is like the city inspector and the structural engineers stress testing our skyscraper, making sure every single weld is strong and that the foundation can handle the load.
And hey, don't just take my word for it. This quote from Atlassian shows just how critical this step is. They call the testing phase fundamental and often the most intensive part of the whole process. So yeah, skimping on testing is the surest way to have your digital skyscraper come crashing down later.
The database is built, it's tested, and it's officially live. The skyscraper's doors are open for business. But the job isn't done, not even close. Now we enter the final and, honestly, the longest phase of the entire life cycle, keeping the system running smoothly, day in and day out.
This is what we call database evolution. Because, let's be real, businesses are never static. New requirements pop up, workloads get heavier, and technology changes. The database has to be continuously monitored, maintained, and updated to meet all these new demands, all while making sure the data inside stays safe and the system keeps working for everyone who uses it.
Which brings us to our final thought. The skyscraper is standing tall. It's serving its purpose. But just like a real building needs maintenance, security, and the occasional renovation, a database is a living system that requires constant care. So is the work ever truly done? Nope. It simply evolves. And that, right there, is the entire essence of the database development lifecycle.